Hello my dear students, I am Kiran Keshagor from FMT Ratnagiri. Today I am going to explain about semiconductor devices, and in previous lecture we learnt about diodes and SCRs, and SCR is nothing but a thyristor. Okay, today we are going to see how that SCR behaves like a two transistor. So today's part of discussion is to explain SCR as two transistor model. So SCR is having four layers: p layer, n layer, p layer, n layer, that is pn, four layers, three junctions J1, J2, J3, and three terminals anode, cathode, and gate. So if we can cut this SCR exactly like this, so it separates and it makes one PNP transistor, another is NPN transistor. So if two transistors are connected in series like this, so we can explain this model as it behaves like two transistors. So for explanation I have taken, this is a P transistor, that is PNP transistor, and this is an NPN transistor. I have shown here. I represent PNP transistor as Q1, NPN transistor as Q2. Then these are the terminals of SCRs: anode, gate, and the cathode. So these are the terminals of transistor 1, that is emitter, base, collector, and this is the collector, base, emitter for NPN transistor. Okay, so we'll see how this model acts. These are the terminals of anode, gate, cathode are the terminals of SCR, and these are the terminals of transistor, and transistor Q1, second one is transistor Q2. So to explain this, I have connected an external load RL across the anode and cathode of SCR because it behaves like an SCR now. And for biasing, that gate biasing, I have given a DC source 2. Okay, and this is the voltage across the load, and when I apply voltage across a source through the anode, and anode current starts flowing, the anode current itself is the emitter current for the Q1 transistor, that is PNP transistor. The next, a collector current starts flowing from the first transistor. Again, the base current is also starts flowing from first transistor, and that base current IB1 is equal to the collector current of second transistor, that is collector current of second transistor is IC2. I have shown here IB1 is equal to IC2. So that collector current is nothing but the base current of previous, that is the first transistor. Okay, now when you apply the gate current using this gate source, IC current and IC current forms a base current for the second transistor. So the base current equation for the second transistor is IB2 is equal to IC1 plus IG. Hence we see the equation for the cathode of SCR, that cathode current is equal to, that is the emitter current of second transistor, and that must be equal to anode current plus the gate current. Okay, next we'll see something, the fraction of holes and electron inject from anode to cathode, or common base gain, is represented by alpha. So in general equation we'll see collector current of any transistor is given by that alpha into emitter current plus base current. So similarly from the circuit diagram we start deriving this IB1, that is the base current of first transistor, is equal to anode current minus IC1, that is this current minus IC1 is equal to the base current, that we know the simple mathematics. Okay, so the collector current of first transistor is given by that alpha plus emitter current is nothing but the anode current here, plus ICBL1 is the base leakage current of transistor number 1. So base equation is given by, base current equation is given by IB1 is equal to IA minus, I have replaced this IC1 as this whole equation. So next, this is, if you take IA as common, you'll get this. Then collector current of second transistor is given by, again this common equation, alpha 2 into cathode current, because cathode current is nothing but the emitter current for the second transistor, plus it is a leakage base current ICBL2 for the second transistor, and we know this base current of first transistor is equal to collector current of second transistor. Next, when you take the equation of base current, that is equal to collector current, that is equal to this whole equation I have replaced here. And we know one more important thing. This is a resubstitution of the equation. You'll get this. You just go through this previous equation. So you'll get this IA minus this equation is equal to this whole part. Okay. Then, but a cathode current of SCR is equal to anode current this plus the gate current. So finally we get anode current of SCR is equal to Ig plus alpha 2 plus ICBL1 plus ICBL2 bracket complete whole divided by 1 minus alpha 1 plus alpha 2. This is what the expected equation for the SCR, that is anode current of SCR, you can say. Thanks for the listening. For any doubts, you just recommend on the box. Thank you for listening. Thank you so much.